Good day, grade 8 students. It's another wonderful day to learn more. Welcome to our radio lesson for Science 8 Quarter 1 Module 1. I am Teacher Yong. Prepare yourselves as we discover more about the world of science. Now get your pen and paper and your self-learning module. So what are we waiting for? Let's begin learning.
Learning science is fun, knowledge for everyone. Learning science is fun, knowledge for everyone. Learning science is fun, knowledge for everyone. Learning science is fun, knowledge for everyone.
Have you ever wondered why things around us are moving and others are not? Well, we think we do know, but we need to know more what factors causes these things to move. Some of us might even ask, how are we able to stand on the earth without falling into the center of the earth? I know what you're thinking. Yes, you are right. Forces. Forces are everywhere. Without forces, dancing, driving, sports, everything would be impossible. In this lesson, you will investigate the relationship between the amount of force applied and the mass of the object to the amount of change in the object's motion. But before we'll proceed, let's check first how well do you know about forces. I've got some questions for you. Let's begin. Number 1. Which of the following describes a force? A. A pull only. B. A push only. C. A push or pull or both. Or letter D. Neither a push nor a pull. Very good. It's letter C. A push or pull or both. Number 2. What is the unit of a force in metric system? A. Calorie. B. Joules. C. Newtons. Or D. Pounds. Great! It's letter C. Newtons. Number 3. How do forces occur? A. In pairs. B. In triplets. C. By themselves. Or letter D. As single quantity. You are right. It's letter A. In pairs. Number 4. When you move a chair across the floor, what force must your push be stronger than? A. Friction. B. Magnetic. C. Normal. Or D. Tension. Very good. It's letter A. Friction. Number 5. A 500 Newton lady sits on the floor. How much force does the floor exert on her? A. 50 Newton. B. 250 Newton. C. 500 Newton. Or letter D. 1000 Newton. Right, it's letter C. 500 Newton. Number 6. Which force always pulls the objects to the ground? A. Applied. B. Friction. C. Gravitational. Or letter D. Tension. Very good. It's letter C. Gravitational. Number 7. A leaf falls from a tree. What force are acting on it? A. Air resistance only. B. Gravitational force only. C. Applied force and air resistance. Or letter D. Air resistance and gravitational forces. Very good. It's letter D. Air resistance and gravitational forces. Number 8. When a cabinet touches the floor, which type of forces exist? A. Contact forces. B. Balance forces. C. Non-contact forces. Or letter D. Unbalanced forces. Yes, the answer is letter A. Contact forces. Number 9. The Earth has a bigger mass than the Moon. If you were able to travel to the Moon, what happens to your weight? A. Increases. B. Decreases. C. Stays the same. Or letter D. Varies with day and night. The answer is letter B. Decreases. Number 10. A box is moved in different direction. On the left force is 6 Newton, while on the right force is 5 Newton. A. 1 Newton to the left. B. 1 Newton to the right. C. 11 Newton to the left. Or letter D. 11 Newton to the right. Very good. It's letter A. 1 Newton to the left. Forces do not always cause motion. This means that a force can be described in terms of what it does. It doesn't necessarily follow that forces acting on an object will always cause it to move. Here are the examples where forces have tendency of changing the motion of an object or not. Example 1. A girl sitting on a chair. Example 2. A boy pushing a wall. Example 3. A woman throwing a ball. What forces can do? Forces can produce changes in motion. And what are these changes in motion? We all have seen a car moving and a car slowing down. When a car starts moving, it speeds up. When a car nears a stop sign, it slows down. The car is covering different displacements at equal time intervals, hence is not moving in constant velocity. This means that the car is accelerating. You have learned this in your grade 7 lesson: displacement, velocity, and acceleration. The ideas were arrived at by studying examples of uniform motion or objects moving in straight line at constant speed. Then, you were able to learn about non-uniform motion where the object covers an equal displacement at equal intervals of time. Now try to put a ball on the top of a table. Let it stay at rest. How can you make the ball move? Great! The ball has to be pushed or pulled. Now what happens to the ball when you push it with enough force? Yes, the ball moves in the same direction as the force. And while it is moving, how can you make the ball stop? Very good! You need to exert a force opposite the motion of the ball. And how can we make the ball change its direction? Very good! The ball has to be pushed sideways. The ball moves once you push or pull it. This is called force. The ball will not move when there is no force applied to it. If you push it, it will move or roll across the surface of the table. And when it is again pushed in the direction of its motion, it moves faster and even farther. But when you push it on the other side instead, opposite to the direction of its motion, the ball may slow down and eventually stop. Lastly, when you push it in a direction different from its original direction of motion, the ball also changes its direction, which means that the force can make the ball or any object move. It can make it move faster, stop, or change its direction of motion. But does this occur always? Can force always affect change in the state of motion of an object? When a force acts on an object, there is line of action, point of application to the object, and point to the direction of the force. Now you need to be familiar with the following terms related to forces acting on an object. Magnitude. It refers to the size or strength of the force. It is commonly expressed in Newton, N for meter kilogram second, MKS system, dyne for centimeter gram second, CGS system, and pounds for foot pound second, FPS system. In the International System of Units, SI, Newton is commonly used, which is named after Sir Isaac Newton, an English physicist and mathematician. Direction points to where the object goes. The direction of the arrowhead indicates the direction of the force. The length of the arrow represents the amount of force or relative magnitude. Points of application. The location of where the force is applied. Line of action is a straight line passing through the point of application and is parallel to the direction of the force. There are two types of forces, contact and non-contact forces. Now let's have first contact forces. Examples of contact forces are: number 1, applied force. It is a force given to a person or object by another person or object. Its symbol is F depending on who or what applies force to the object. If a boy applies a force to the wall, we denote it with F boy. Another example of contact forces is friction. It is the force acting against or opposite an object in contact with, which makes the movement of the object slow down. Friction always opposes the motion of an object. Its symbol is written as FF, capital letter F and small letter f, which stands for friction force. I know you have tried flying a kite, or watching an airplane, or parachutes, or those in skydiving sports. Air resistance, denoted by F air, is an example of frictional force of the air against those things. For free-falling objects, this force is always considered negligible, meaning the magnitude is unnoticeable. Another example is normal force. It is the force that acts perpendicular to the surface of the object in contact with. Its symbol is Fn. Now let's have non-contact forces. These are forces where objects do not touch or contact with each other. These forces act over a zone or area called field. Examples of non-contact forces are gravitational and magnetic. Do you know what causes objects to fall down to the ground, or make satellites and smaller objects stay in orbit near the more massive planets? This is caused by gravitational force, or F sub g. Mass and distance of two objects affect the gravitational force that holds them. For example, the Earth and the Moon. Earth has bigger gravitational force over the Moon. The bigger the masses of the objects are, the bigger is the gravitational force between them. The closer the objects are, the greater is the gravitational force between them. The weight of an object, denoted by W, is an example of gravitational force of the Earth towards the object. Example: a book on a table. The weight of the book on the table with normal force. However, the weight of an object depends on the mass of the celestial body where the object is attracted to, meaning we seem to be lighter when we are on the moon than on the Earth. Another example of non-contact forces is magnetic. These are forces exerted on a field of attraction or repulsion, as in the case of magnets and other magnetic materials. I know you have played magnets in your childhood. Magnets and magnetic materials have two poles, the north and south poles. Attraction may occur when two poles are not the same, a positive and a negative, while repulsion takes place with the same poles, positive, positive, and negative, negative. Opposite poles attract, like poles repel. Now let's have balanced and unbalanced forces. To describe a force, you must know two things. You must know the magnitude and the direction of the force. I know you have played tug of war before. There are two teams, Force A and Force B. Each team is pulling with equal magnitude of force on the rope but in opposite direction. Neither team can make the other team move. Forces that are equal in magnitude but opposite in direction are called balanced forces. Balanced forces do not cause a change in motion. When balanced forces act on an object at rest, the object will not move. Now when you push a table and then it moves, unbalanced forces are present. Forces that cause a change in the motion of an object are unbalanced forces. These are forces that are not equal and in opposite direction. Now let's go back to tug of war. Force B exerts greater magnitude of force than Force A. The forces applied on the ground would no longer be equal. One team would be able to pull the other team in the direction of the larger force. This is unbalanced forces. In an object, there may be several forces acting on it. Net force or resultant force is the sum of all the forces acting on an object. Two or more forces in the same line of action exerted on an object are balanced if their effects cancel each other. When an object is at rest, meaning it's not moving, a zero net force would make the object remains at rest. Moreover, when the object is moving, a zero net force would make the object maintain its velocity at the given time interval. Now on your activity sheets, let's have Activity 1, Forces an Object at Rest. After accomplishing this activity, you should be able to identify what forces are acting on an object at rest. Let's have a block of wood lying on a table. Is the block of wood at rest or in motion? Very good! The block of wood is at rest. Now, can you draw the forces acting on the block of wood lying on a table? And what are the forces acting on it? Very good! Forces acting on it are frictional force, tension, normal, and gravitational force. Let's have Activity 2. After performing this activity, you should be able to examine the situation when the forces are balanced and explain the effect of balanced forces on the state of motion of an object. Now, let's have tug of war. Force A is applied force on the rope by Team A, and Force B is applied force on the rope by Team B. This is balanced forces. If two groups in the game are exerting equal and opposite forces on the rope, will the rope move? Great! The rope will not move because both teams are exerting equal and opposite forces on the rope. In the same condition, what happens to the net force acting on the rope? Zero. What are the forces present on the rope? Yes, you're right. Tension and applied. Now let's check how well have you learned for today's lesson. Choose the letter of the correct answer. Write your answers on your activity sheets. Let us begin. Number 1. Which is not a unit of force? A. Dyne, B. Joules, C. Newton, or D. Pound? Great! The answer is letter B, joules. Number 2. What refers to how large or strong is the force? A. Magnitude, B. Line of action, C. Velocity of the object, Or letter D, direction of the force? Great, it's letter A, magnitude. Number 3. What force is always directed opposite to the motion of an object? A. Friction, B. Gravitational, C. Magnetic, or D. Tension? Good, it's letter A, friction. Number 4. What force pulls an object back to the earth? A. Applied, B. Gravitational, C. Magnetic, or D. Tension? You got it right, it's letter B, gravitational force. Number 5. Which surface would be easiest for a bicycle to move? A. Sand, B. Grass, C. Muddy road, or D. Concrete road? It's letter D, concrete road. Number 6. What type of forces holds between two celestial bodies like the Sun and the Earth? A. Applied, B. Gravitational, C. Magnetic, or D. Tension? You are correct, it's a letter B, gravitational. Number 7. What force acts perpendicular to the surface of an object in contact with? A. Applied, B. Gravitational, C. Normal, or D. Tension? Great, it's letter C, normal. Number 8. Two people pull on a rope in a tug-of-war. Each pull with a 300 Newton force. What is the net force? A. 0, B. 300, C. 600, or D. 900? Very good, it's letter A, 0. Number 9. Planet Jupiter has a bigger mass than the Earth. If you were able to travel to planet Jupiter, what happens to your weight? A. Increases, B. Decreases, C. Stays the same, or D. Varies with day and night? Nice, it's letter A, it increases. Now what is the force of a box with 100 Newton on the right force and 85 on the left? A. 25 Newton to the left, B. 25 Newton to the right, C. 195 Newton to the left, or letter D. 195 Newton to the right? Very good, it's letter B, 25 Newton to the right. You did an amazing job today. I hope you enjoyed learning forces. Until next time, be cheerful and stay safe.